Award-winning Lulzbot 3D printers now come with ready-to-print profiles for polycast, a filament designed for investment casting applications where dimensional accuracy and surface finish are essential. It prints like standard PLA plastic, which makes it super easy to work with. But the main thing that makes polycast special is the ash-free technology, which makes it easy to burn off during the casting process. We teamed up with our friends at Art Castings of Colorado to put the new polycast to the test. We've been getting a huge response from folks using our printers in the automotive world. So for this project, we designed and printed a bunch of different car parts, like these simple ring and pinion gears, and a few complex pieces, like this turbocharger assembly with intricate internal chambers and support material. From there, we lightly cleaned up the support material using an X-Acto knife and some 800 grit sandpaper. Next, we treated all our parts to a bath in isopropyl alcohol to smooth layer lines. We dipped each of these parts several times before hanging them overnight to dry. This step is important for sealing tiny cavities that may corrupt the casting process. From there, we headed over to Art Castings of Colorado, where our prints would be cast over the next 2 weeks. First, our parts were mounted to a cup assembly or parts tree. Bars of wax called sprues are cut to size and attached to the prints to ensure the metal flows slowly and evenly into the piece. Technicians use a small torch to eliminate any holes in the sprues or the parts tree itself. Next, the parts move to the dipping station, where they're submerged in a ceramic slurry, sprinkled with fine silica compound, and left to dry. This process is repeated a few times over the next several days, creating a thick outer wall that will survive high heat from the kiln. The parts are placed in a 1600-degree kiln for a full 2 hours. Polymaker boasts an impressive 0.003% remaining ash residue, and the foundry techs were quick to mention how much better the polycast burned out than other plastics they've seen in the past.
One way I test to see if there's debris in the shell is I blow air into it, and if any ambers come out, I know there's still plastic in there. But this plastic seemed to have less debris inside the shell.
From here, the ceramic casings are filled with water to test for leaks, and a quick dab of mortar seals any holes. Then it's back into the kiln, where the molds are brought up to temperature to receive molten metal. Bronze is then heated to 1600 degrees in an induction furnace, while stainless steel is heated to an insane 3000 degrees. The pour happens very quickly, and the parts are left in front of a fan to cool. A pneumatic jack rattles the ceramic coating from cast parts. And a technician uses a plasma cutter to remove parts from their tree. The trees will eventually get melted down and reused for other castings. Finally, our bronze parts get treated with sulfurated potash and baked in another oven before receiving the final treatment of ferric iron for that signature bronze patina. And a sealant is applied to all the pieces to protect them from corrosion.